We are the next generation of aerospace engineers. We have a lot of work to do. The world is going to be moving into space, and we want to be leading that charge.
Lura is an outlet for students to kind of scratch the itch of engineering and hands-on learning through rocketry and aerospace projects. Our goal is to teach rocketry to as many students as possible, but our overarching goal is to be world champs in both liquid and solid rocketry and push the limits of collegiate rocketry in general.
I joined Lura when I had a friend and she's like, Annan, there's this club and it's rockets. And I go, oh my gosh, that sounds so exciting. And I'm like, I want to be part of this.
April of this year of 2026 will be our 2-year anniversary. Our first big milestone was our first ever L1 launch. And then from there, we developed the Level 1 program, where we started launching 10, 12, 13 rockets at a time and coming back with 100% success rates. Everyone was getting certified.
The first test flight I went to, we get there, like, I feel like the air's changed, the wind's roaring, and the adrenaline of watching your rocket on the launch pad, and then like finally seeing it go up, and then the adventure of tracking it down. It's something that truly can't be compared to.
From there, we started working on our liquid rocket.
This is called a stacked tank design. So we have a free-floating piston in the middle, and then we have nitrous oxide that gets loaded in the bottom, and like a light hydrocarbon sitting at the top. When we open the propellant tank valves, as the nitrous oxide leaves the tank, it's going to self-pressurize and push that piston upwards. And it'll push the fuel out into this downcomer. And all this gets mixed into the chamber, and then we ignite it, and the magic happens.
The static fire of that rocket last year was so successful and such a huge milestone. I'm very excited for it all, and it's all come together. And it's been a long road, but one that we're just happy to be going down.
3, 2, 1, and liftoff. Liftoff of Challenger in the first flight to repair a satellite in space. We have cleared the tower.
Well, we have wonderful students here at Lehigh, and I have the privilege of seeing them in the classroom, of course, when they take my aerospace courses. But also I'm the advisor for 3 different aerospace clubs that do airplanes, rockets, and spacecraft and rovers. Our job in the faculty is to give them the tools to learn and to cultivate that passion and watch them take off.
So yeah, the NASA capstone project, that was an amazing project. That was so exciting to see that come together and work over the 2 semesters we've worked on it.
The goal of our project was to design a VTOL, vertical takeoff and landing drone, and our application was geomapping. So take off from ground, transition to forward flight, and then be able to scan and survey and create topographic maps of areas. Yeah, I was responsible for flying the drone, which is a very, very fun and incredible job to have, but also a pretty nerve-wracking one. The best part of the test is when it touches down the ground, still one piece. That was the best part, actually.
One of our biggest projects here is our IRAC rockets. That's the International Rocketry and Engineering Competition. And this rocket next to me is Talon. We have a robotic dog payload, which I believe is very, very strong payload design.
This robotic dog is going to be inside of our competition launch vehicle. Like Keegan always says, they put men on the moon, so we could figure this out.
Exactly.
We really want to win IRAC. We want to show that we are the best rocket club in the world and that we've done it in just over 2 years at that point in June. Even if we could do well and place very high, it's just such a credit to our entire team.
We're going to go with Talon in 5, 4, 3, 2, 1.
This is what humans have to do. Like, we have to be engineers. Like, we've always been engineers. I really believe that this generation will see multiplanetary life, and this generation will be the one to do it. And this generation behind me of aerospace engineers wants to do it and can do it.
I want to work at NASA. I want to be creating new materials that are going to take us further and faster, and just even being any small part of that would mean the world to me.
Obviously, we want the club to grow. We want to be the biggest engineering club on campus. Currently, we have over 40 members, and I could see that number being over 80 members. I feel like the sky's not the limit with a club like this, and I'm very happy and very honored and very thankful to be the president of it.